Okay, we're going to look at rational inequalities now. Again, we'll be factoring, considering multiplicity of the roots. But the interesting thing about rational inequalities is your denominator is always a open circle, meaning you never could include the zero in the denominator because that's where you have an asymptote. So factor, consider the roots, consider the multiplicity of the asymptotes as well as the intercepts, and then the inequality symbol. So x squared minus 1 is the difference of two squares, so that's x minus 1, x plus 1, all over x is greater than or equal to 0. So I'm just going to draw a number line here. I really don't need to draw a graph. I just need to write the critical numbers, which is 1, 0, and 1, because 1, -1, and 0, that's a -1, sorry. So the critical number of the denominator is always an open circle. The numerator, since you can have 0 in the numerator, that just gives you 0, which is just an x-intercept. Since it's greater than or equal to, this circle right here is a closed circle, and this is a closed circle as well. So since all of these have odd multiplicity, that means on either side of the root or the asymptote, the sign is going to change. So the only thing we need to do is figure out the sign of the first one here, and then we can just change every sign because all of these had odd multiplicity. So let's just choose a number way over to the right of 1. I like to choose 10 because that's an easy number. So if I plug 10 into this function right here, I get 10 minus 1, 10 plus 1, all over 10. Well, that's 9 times 11 divided by 10, which I know is greater than or equal to 0. That's a positive number. So this is positive, and the sign changes because the odd multiplicity of the x, odd multiplicity of the -1. So it's positive, negative. We want when it's greater than or equal to 0. So therefore, the regions we want is this region here and this region over here. So including -1 but not including 0. So a bracket on -1 and in parentheses on 0. And then 1 to infinity. Or we could have written it as -1 is less than or equal to x is less than 0. Or x is greater than or equal to 1. So let's first factor this. This is trinomial squared, so therefore it is x plus 5 quantity squared. My denominator is x minus 2, x plus 2, that's less than or equal to, less than or equal to 0. So my critical numbers, this is critical numbers -2, 2, and -5. So -5, -2, and 2. And we want the denominator values aren't always going to be open circle because you can't have 0 in the denominator. So this is open circle and open circle. Since it's less than or equal to, and this is the -5 is a critical number of the numerator, this is going to be a closed circle. So this is only closed because it's a critical number of the numerator and it's an equal to symbol. So again, we just need to figure out the sign all the way over to the right, and then it's going to change sign at -2 and 2 because both of these are odd multiplicity, and it's going to stay the same sign on either side of -5 because this is squared, even multiplicity. So a number to the right of 2, a good number is 10. So 10 plus 5 squared, that's a squared, all over 10 minus 2, 10 plus 2 is equal to 15 squared, positive, 8, positive, 12, positive. So this is a positive number. So that means it's positive over here, odd multiplicity, sign changes, odd multiplicity, sign changes, even multiplicity, sign stays the same. So the only regions in which my function is less than or equal to 0 is it's negative right here. It's also 0 at -5. So we write our answer as x equals -5 or -2 to 2. Or you could have written it as x equals -5 or -2 is less than x is less than 2. Okay, here we need to do some common denominator work, and then we'll consider the roots and the multiplicity. Let's move this 7 over. A common mistake, so this is wrong, is to multiply this whole function times x. So I get x squared plus 12 minus 7x is less than 0. So x squared minus 7x plus 12 is less than 0. So I factor it, I get x minus 3, x minus, let me fix that. So that's what I get if I multiply everything by x. By getting rid of this x in the denominator, I end up with just a parabola with -3 and -4. Now let's do it the right way and see how it looks different. So here I'm going to get a common denominator, so therefore I need to multiply this one by x over x and this one by x over x. So let's just choose a different color. So this needs to be multiplied by x over x, and this needs to be multiplied by x over x. So now all three have the same denominator. So this is x squared plus 12 minus 7x all over the common denominator of x is less than 0. You don't want to get rid of this x. You don't want to multiply both sides by x and get rid of that. You want to keep this x because this is a critical number. So therefore, let's rewrite it. 7x plus 12 all over x is less than 0. So we get x minus 3, x minus 4 over x is less than 0. I need to give myself some more room, so hold on. Okay, so notice that these two look very similar, except there's an x in the denominator. Well, x is a critical number, namely 0. So when we write out the number line here, we have 0, 3, and 4. We have 3 critical numbers, as opposed to over here we only have 2. So you never want to get rid of your denominator when you're dealing with rational inequalities. So again, we need to look at a number to the right of 4 and see if it's positive or not. So let's just give ourselves a little bit of room. Let's plug in 10 because 10 is bigger than 4. So that's 10 minus 3, 10 minus 4 all over 10. So this is 7 times 6 over 10, which is positive. So that means this is positive. All of these are odd multiplicities, so the sign is going to change at each point. And all of these are open circles because this is less than, so that means your denominator value has to be open circle because it's in the denominator. And since it's less than and not less than or equal to, both of these have to be open circles as well. So we want when the function is negative, so less than 0, so that's going to be this region over here and this region in between those two. So therefore that's going to be negative infinity to 0, or between 3 and 4, or x is less than 0, or 3 is less than x is less than 4. Okay, another common mistake is to take x plus 2 over x minus 4 and cross multiply, get x plus 2 equals x minus 4. And then in this case, these two x's cancel and you get 2 equals -4, which is never true. But actually, if we kept the inequality statement, it would be true, it would be greater than or equal to, so that would be always true. But the whole problem is we got rid of the denominator. You don't want to lose your denominator because that's a critical number. So in here, what we want to do is move the 1 over and get a common denominator. So let's move over the 1, so that's -1 is greater than or equal to 0. And now we need to get a common denominator. This already has a denominator, so this just needs x minus 4 over x minus 4. So my numerator becomes x plus 2 minus x minus 4. Notice I put this in parentheses, all over x minus 4, greater than or equal to 0. So this is x plus 2 minus x plus 4 all over x minus 4 is greater than or equal to 0. Notice the two x's cancel out. I'm left with 6 over x minus 4 is greater than or equal to 0. Notice I'm leaving it in this form. I'm not going to cross multiply and get rid of the x minus 4 because this is a critical number. It's in fact our only critical number, because what makes the denominator 0? 4. What makes the numerator 0? Nothing. The numerator is always 6, so there's no critical number out of the numerator. 6 is not a critical number. Since it's greater than or equal to, we don't have an open circle. This is going to be, don't have a closed circle. This is going to be an open circle because your denominator can never equal 0. So all we need to do is to determine the sign to the right and then the sign to the left, because it's odd multiplicity, will just be the opposite. So let's choose a number larger than 4, which is 10 is a good number. So we get 6 over 10 minus 4, which is 6 over 6, which is positive. So therefore this is positive and this is negative. so therefore we're looking for greater than 0. So my solution will be 4 to infinity, or x is greater than 4. Okay, our last example is we have two rationals here, so we're going to put them both on the same side. Doesn't matter which direction I go, I'm just used to having things on the left-hand side. So I'm going to move the 5, leave the 5 over x minus 3 here, and I'm going to give myself a little bit of room, and x3 and x plus 1 minus greater than 0. So the reason I gave myself a little bit of room is I need to get common denominators. So again, never get rid of your denominators, get common denominators. So this needs to be multiplied by x plus 1 over x plus 1, x minus 3 over x minus 3. So we get 5x plus 1 minus 3 x minus 3 all over my combined denominator of x plus 1, or my common denominator. So now I distribute, so I get 5x plus 5 minus 3x plus 9 all over x plus 1, x minus 3, 2x plus 14 all over x plus 1, x minus 3. So this is greater than 0, greater than 0. Take a greatest common factor of 2 out of the numerator. I get x plus 7, x plus 1, x minus 3. So in this case, the critical numbers are -7, -1, and +3. So -7, -1, and +3. Since it's greater than, not greater than or equal to, everything's going to be an open circle. We need to choose a number to the right of 3 and see if it's positive. Let's choose 10. So we get 2 times 10 plus 7 all over 10 plus 1, 10 minus 3, which is equal to 2 times 17 over 11 times 7, which is positive. Since all three terms are of odd multiplicity, this sign is going to change at each value. So we start off positive, negative, positive, negative. We want when it's greater than 0, so that's going to be between -7 and -1, and to the right of 3. So we write our final answer as -7, -1, parentheses, because you're not including those points, 3 to infinity, or -7 is less than x is less than -1, or x is greater than 3. That's the end of rational inequalities.